Welcome to another cool ChiliPeppr tutorial video. There's a new feature out this week. It's the solder mask tab inside the Eagle board widget. And what it does is it lets you create Gcode paths to laser out or mill out your solder mask. So it's sort of the next step beyond just milling the basic traces. You then want to lay on a solder mask and then be able to manipulate it. So I'll show you a few ways to manipulate it with a laser, but you could also use an end mill as well with this new Gcode creation capability. Okay, I'm going to show you how to make a solder mask Gcode file inside ChiliPeppr. So what we do is we bring in our Eagle board file, just drag it into ChiliPeppr like you would some Gcode, and notice the Eagle board widget automatically pops open. And there is a brand new tab, this awesome new tab called Solder Mask. You click it and it renders the path and generates the Gcode. And notice you've got these red paths that you can use to laser out the solder mask. So the idea would be that you cover the board in solder mask and then you come back with the laser and you ablate the pad. Notice these little paths. You can see they're semi-transparent, but where they overlap, you can kind of tell where the laser will go over it multiple times. Now, if you look, there's this option called, well, I'll take you through them slowly, but you can also show the rendering just as path lines of where your laser would go. And so that kind of makes sense just to understand what the final Gcode path will look like. It's nicer to me to show it as a solid line because you're going to see the width of the laser. So if you want to up the width, let's say I up it to 0.4, just click out of it and it'll re-render. Notice though you get a warning. Some of your pads cannot get a path rendered because the laser's too wide. Most lasers you can get pretty tight, so shouldn't, 0.4 is probably not correct. Let's say you have a really nice accurate laser, like a 0.1 millimeter. Again, I just changed that number and then I click off of it and you get some nice paths looking there. I like to use 0.2 for my 6-watt laser. The overlap of paths is worth noting as well. Let's really jack that up to something like a 50% overlap, and then I'll click out of it and it'll re-render. And notice that you'll get just more, you get a lot more laser overlap there so that you get some stronger paths. Notice too, let's say I did 0% on the overlap of paths. I get, some of these don't actually render. So you really got to play with these settings to decide what makes the most sense. The default is 20%. So the other thing to take note of is whether you want to laser this or mill this. So let's say that you actually want to mill it instead. It doesn't change the way this renders, it just changes the way the Gcode's generated. And then your feed rate is the most important part. And then of course you could send your Gcode to workspace down there. With the lasering, there's 4 options now. One is just what a lot of people do is the M3 spindle. Sorry, I gotta switch over to laser. When you do the spindle, you can put your S value in. If you have a TinyG, it shows you the settings to pass in to kind of make your PWM be somewhere between 0 and 1. And so 1 would mean 100% power, 0 would mean 0%, or say that for 50%. Some people are using the M8 just to toggle it on and off. You don't end up with PWM on that. In the new G2 core, there are some output ports. And so you actually have the choice of doing that. This generates the new G2 core's out command. It's like a general purpose IO. And then Cayenne is actually what I use now. I will show that in a future video, but it is my laser is controlled by an ESP8266, and you can send JSON commands to it in real time that synchronize with the TinyG. Pretty cool feature. For now, we'll leave that on spindle. And so this is the way I'm going to mill out my my solder mask is with this Gcode, so I'll go ahead and send the Gcode to the workspace. And then once you do that, you can kind of see it in here at the same time, but you can only really see it from the bottom, the blue line. So the best thing to do is just turn off the widget. And there is your Gcode ready to run. Okay, I'm going to ablate the UV curable solder mask. I've already laid the solder mask on and UV cured it, so it is solid. And you can see the copper comes through really nicely with this ablation technique. This is probably my favorite technique to use for creating the solder mask. You do have to do a little bit of cleanup on that copper to solder it well. And then in this example, I'm lasering out some high temperature red engine spray paint. Got ceramics in it. And it doesn't resist solder as well in terms of sort of having it beat up, but it does work as a quick method. Okay, now I will also show you how I do my Gcode for the cutting out of vinyl. So there's another option in here which is outline only. And in this case, notice that we're just cutting the outline of the pads, and you get some extra features when you choose outline. You can do it outside the pad, on the line, or inside it. For me, I want to go outside because I want the vinyl to stay 100% on the pad, so I want to laser the vinyl on the outside of it. And then there's one additional choice, which is to include dimensions, and that will also laser your vinyl on the outside. Now you might be able to use this for other stuff than vinyl. Leave it up to you, but you've got enough choices here that you've got a lot of ways to mill or laser out a solder mask. So let's get going with actually running this job. Here I am lasering out the black vinyl. The vinyl has a sticky backing, so you just lay it onto your copper clad. The laser is absorbed pretty readily by the black, so you don't need a lot of power. You can see it cuts pretty cleanly, and then you just peel the outer portion off, leaving the black vinyl over your pads so you can do further processing. Thank you for watching.